What you see here right on my screen is the summary of the topics that we are going to cover in our course. And initially, we will have some Linux basic training. Mainly, we have a few many freshers in this class actually. So initially, we will start with the Linux basics training. That is the beginning. You need to understand some basics of Linux before we can go on with the tools and technologies. When you start with the advanced topic like Jenkins, Chef, then Docker, all those things. Initially, the basics of everything is Linux. All the tools are running on Linux and they are based on Linux OS. So initially, we will have a Linux training. About it would take about up to 10 hours, maybe total 15 hours, including scripting. We will also have some scripting training, which include shell scripting and Python programming. Shell scripting is the Linux shell scripting, and Python programming is a different programming language. Actually, probably you have heard of it. And it both are in a intermediate level, not in a very advanced level. You are not expected to know the advanced programming, just a intermediate level programming, so that whenever sometime you come across some situation you need to write a script to automate something, you should be able to. That is the intention of the scripting included in this topic list, right? And after this and then we will see how to set up the website, basically how you can run a web application on a server. How to create a website, uh, to be in fact, and some database technology like MySQL, MongoDB, etc., so that you will understand the application better. Typically, a software, sometime I call it software, sometime I call it application. Both are same. Make a note. Sometime this application want to save data in a central place. For example, think about the Uber application or Ola application or any Google. Think about Google. All of them want to save their customer data, right? In case of Uber, they want to save the passenger data. There can be billions of passengers and maybe millions of drivers out there. All those details, their car number, then their location, their address, their phone number, mail ID, any contact information, all those information should be saved in a central place, a database. So we will be learning. This is a very basic training. We are not going to advanced level, but you should understand what is a application or what is a software better. That is why we have included some lab section for that, which is included along with the Linux training. Apache, Tomcat database, and we are also learning some PHP frameworks, WordPress, and Drupal. These are PHP frameworks. I did not put that in the slide. So about 15 hours, these total things will take scripting as well as Linux administration topics. And after that, we will start with our advanced level topics. Okay. It includes cloud computing on AWS. This is a advanced level course. Will take about 15 hours. I think exactly 15 or 15 or 16, somewhere around that. We will be covering, there are different services offered by AWS. I will tell you what is cloud computing first, right? Cloud computing is something like when you wanted to purchase your computer for the first time, you went to the shop, you paid him, and they told you the specification. Then you selected the specification, then you paid him, and he need to assemble all the setting. There is CPU, there is RAM, then there is hard disk, there is a cabinet, there is a monitor he need to buy. So he will buy everything as per the specification that you have given him. Then he will assemble the parts together to create the PC, and then they will give it to you. You will buy it, take it to home, and you need to then install the operating system, right? You need to install Windows in it, then only you can use it. Then after installing operating system, you need to install all the drivers, software, everything. right? So the entire process can take a very long time. So instead of that, think about the situation. You are buying a machine and you have the option to choose. Let's say from your browser, you log into a cloud computing provider. You have the option to choose how much CPU you want, how much memory you want, how much hard disk you want, then what software, what operating system should be running on the machine, and even what software should be installed on the machine. You can specify all those specifications, and then you can create a machine, and the machine is getting ready within couple of seconds. And that is what happening today. People, when they want to buy the machines, it takes hardly couple of seconds today because of cloud computing. I'm not talking about the machine that you use in your laptop, probably the operating system that you use in your laptop, probably the machine which you can use for some different purposes. For example, when you access google.com, your request go into a google.com server, maybe a machine that is owned by google.com, probably it is running a Linux operating system or maybe Windows operating system, and the machine is responding you with the google.com pages. So those machines are not your laptops, those are different machines, probably you call them servers or something, and those machines serve special purposes. So if you want to set up that kind of machines, it is all about, you can actually go with a cloud computing provider and it would take you hardly 2 seconds, and this was not the case earlier. It was the same process as how you would purchase a laptop or how you would purchase a desktop for your home. The process was same, but nowadays with the invention of cloud computing, it is very easy. You specify everything, you click on a button on a browser, and your machine is ready, and you get the login credentials to the machine where you can log in and start working. So we will be discussing in detail, and these are different services which is covered in AWS. These are covered in detail in our course, and probably most of you know, this is a more like a job oriented training. We will see how the typical uh, multi-tier infrastructure, basically every google.com website itself. Think about google.com website. What google.com need to do here is they need to set up their infrastructure. Basically, it will contain a number of machine and a number of network devices, maybe thousands of computers would be there. So whenever people on the internet, this is me accessing google.com on my browser, I am going to hit one of these machines to get my google.com pages. That means Google should have kept this infrastructure ready so that whenever somebody is requesting the page, they should be able to get it, right? So that's what it is, and that's what a server machine is. Typically, these kind of machines are called servers.
So it means in this class we can modify the templates, everything on that in the ship.
Mm, could you come again?
Regarding that, okay, when the environment, okay, the Google environment, okay, they need the one template for building the servers. So
Mm.
in the we can modify and we can do on that in the step environment.
It is possible, and we will talk about that later. Yeah, you can. What you said is right. There is a possibility you can make a change in a template to make a change in your systems. We will be discussing about that.
So you're saying that you need to train by at the infrastructure level. It's like one organization needs the infrastructure change. Like okay, right now they have the
Mm-hmm.
they have Windows and VMware right now. They're looking for DevOps right now. So
Mm.
totally, what is it? Just I need to a little bit know here. I need to
Yeah,
know.
I
So
understand.
you need to
Now what
by
I'm saying is,
infrastructure level. you have tools. What is the tools work on that?
Yeah, we will come to that. Actually, we are coming to that. We are just in AWS yet. So when we discuss about the tools, we will discuss that. We are learning Chef for that actually. To answer your question, Chef is the tool which we are learning for that purpose. I'm coming to that. All right. So this is how it will be. So every company that owns a product should have a infrastructure that will contain a number of machines which are ready to serve people on the internet, right? So that is the infrastructure. This is so. If you want to add a more machine into this infrastructure, it should not take much time because the internet is very dynamic. You don't know how many people is accessing the website right now. Maybe in the next second, how many people are going to access the google.com website. So depending on what traffic are you getting, you should be very dynamically able to add more machines to handle the high traffic. Right now there are 1 million users requesting for google.com website, and in the next second it became 1.5 million. So whenever you need to, probably within 2 seconds or maybe within couple of minutes, you should be able to add more machines to the infrastructure so that it can serve more people, right? So these kind of dynamics have been improved a lot after the invention of cloud computing. Earlier this was never possible. I mean, it was the same process. You would buy the machine, some there would be some data center, some physical room, and it is owned by a provider. You will order a machine from them. They will do the same process. They will go and buy the machine. They will order it. Probably it will take a week to deliver the machine. Then they will take the machine and put into a rack on on their data center. Then they will install the operating system as per what you requested and do the same steps as you would buy a machine for your home. Now nowadays that is not the case. You will get the machine very instantly. These are actually not physical machine, but we are not going into depth for that. But today's infrastructure is very flexible. Whenever you want to, you can get it in couple of seconds, the machines. All right, so these are the services that we are going to cover in AWS. EC2, VPC. EC2 is where I told you you can buy the machine. It is not just the machine that you can buy from AWS. There are a lot of service that AWS provides. We will take a deep look in our course. EC2 is the place, is one service provided by AWS which you can where you can buy the machines. VPC is a networking service in AWS. The physical network, AWS has set up a virtual network environment, which means actually you are uh, it will look real. Basically, you can set up a network in the cloud which includes your machine, whatever machine that you create in EC2, they can be put into a network. So you can have your own network in VPC. Every AWS customer we can create their own network and add their machine into that network. I mean, don't think too much. I'm just this is just a brief introduction about what these services are, and uh, we will go in depth once when we start the class. And one request, if you find any delay in my screen or if you find any problem as such, please let me know. Or if my voice is breaking, if you find any kind of issues, please let me know. All right. I think everything is going well. Sometimes you would find the screen is delayed. If that is the case, also, please let me, or just give me 1 second. I will make sure. My home internet is not so good. I don't want to take the risk. Okay. And like that, okay, and like that there are different services. S3 is a storage service. Basically, if you want to save some files into the cloud, maybe the very big files, maybe if it is, doesn't matter whether it is 1 terabyte in size or it is 1 KB in size, doesn't matter. All those files that you have can be backed up into the S3 storage that is provided by AWS. Like that, we have CloudWatch, IAM, SES, RDS, CloudFront, then some command line tools. These are the things that we are learning in AWS. Command line tools is something I told you, from your browser you can open AWS page and you can create the machine, right? The same job you can do by running some Linux commands, or maybe using some Python script. The same job, you want to create a machine, if you can either create the machine from logging into your browser, then click on create machine, or you can run some script which will create the machine. There are two ways to do that. And EC2 command line tools and Python bottom modules are few command line tools that will help you work with AWS. And after this cloud computing training, we will move on to our DevOps training, which will include Git and then Jenkins, Docker, Vagrant, Nagios, Chef, uh, Nagio, then Nexus, and Sonar. Actually, ever since this DevOps has implemented, a lot of tools came into the market. I will tell you what DevOps is, then I will come back to these topics. All right. Let us go ahead and take a look at the brief introduction about DevOps. What is DevOps? So before that, what is a software from scratch? Something your developers had developed, right? Your business need a software. Your business is helping people book a cab application, helping people book a cab or taxi. Then you need a application for that, so that people can book the cab using their mobile phones. That is a business requirement. So every business will have some product which is there in the market, and that is the product which is generating them some revenue. Google.com is a search engine, that is what generating revenue for Google. Google will put some ad into the google.com website and in the search results, and they will get money for that. So every company will have a product which helps them do the marketing. I mean, which helps them in the market. So think about Uber. The complete money is coming from the application. People always use their mobile phones to make the payment and book the cab. So let us take a look how these softwares are developed. Uber application that you see in the Android market, that is a software, and it is developed by one or multiple developers. Typically not one, typically it is hundreds of developers would be working on that product whenever they would need to. For example, they need to add more features to the product, they need to make some bug fixes. For example, sometime you found that the Uber company had found that people are not able to book a cab from Bangalore location. It's a serious problem, and that work is assigned by the business team to the developer, and developer will pick that work and he will start working on it. He will fix that problem. Probably then he found that, okay, he forgot to add the Bangalore location into the whitelisted areas, then he added it, then now it started working. So like that, there can be bug fixes, or there can be a serious business issue. Your business team found that there is a competitor cab application service who is very fast in the market. They are adding a lot of features into their product. For example, those who is using that cab application, they can actually see the driver in the Google map and see the driver moving towards him, and also the estimated time it is going to take. Everything he can see in the competitor application. So I want the same feature to be implemented here. Otherwise, there is a good chance that a lot of my customer will start using the other application and I will lose customers. So that is a request came from your business, and that is assigned to another developer, and he will start working on that. He will implement the feature of driver tracking mechanism in the application. So typically it is the developer who is making changes to your software, and it is very important to the business that your software should get the latest update very frequently if you want to stay in the market. That is the business situation today. So there is nowadays there is no difference between business and IT. Any problem that you face in IT is considered as a business problem, because that much dynamic is today's market. Ever since the DevOps has come into picture, which means if you are not giving proper updates to your software in time, you are not going to lose in the market. That is the simple principle. Basically, you should be able to make changes to your software product whenever you need to. Just an example, in Bangalore, Ola came first, and Ola was very popular. They had a lot of customers base, and everyone started using Ola, and all the traditional taxi drivers also switched themselves to Ola cabs. And then Uber came later. What Uber had which Ola did not have was a good IT. They had a good IT team. They are capable of whatever developers are working, they can put those changes into the Android market. That means they are making changes to the software very frequently, so that the software will get maybe daily updates. Even they don't really need to put that into the Android market. They can actually, without putting that into Android market, they can make changes to the application, and they are doing releases very frequently, so that they can actually change their product whenever they want to. And what they did is, during the daytime, that means at that time there would be a lot of cabs free between 11 a.m. to 5 p.m., or whenever the traffic is not very busy, there would be a lot of cabs at the stations. And sometimes it is unpredictable. You don't know when the cab will be spare, when the cab will be used. It is unpredictable. So what Uber did is, they did some real time analytics. They found that if they found that there are more than 100 cabs free at this particular location, they will start giving some offer automatically to that location. That means they are changing their product depending on the market need. At that time, you need to give some discount so that you will get more cab booking. Then people started believing that, okay, most of the time you get discount from Uber, and most of the time you will start to believe that Uber is comparatively cheaper than the other competitors. Actually, that is not the case. Uber is doing their marketing. They are just using the spare cabs and giving some discount so that the spare cabs will be used. They are actually making some money out of it. But people get the impression that they are getting a very good discount, and Uber is more user friendly also due to all these features. I mean, they are making their application themselves whenever they want to. You don't need to really bother about anything else. Everything is in place. So it is also very user friendly also, and it is more like giving you most lot of discount, and you have a lot of cabs also available with Uber, and people started moving towards Uber. It does not mean that Ola did not have money to invest, or there is nothing like that. What the winning company had is a good IT which is able to make changes to the product whenever they want to. Maybe you need to make 10 changes per day, you should be able to do that. Maybe 10 a.m. you do some changes so that people will start seeing some discount for spare product, and at 11 you would do one more deployment. So whenever you want to do, you are ready to do. Your infrastructure should be that much dynamic, and that is what DevOps is trying to solve. I'll just give you a brief introduction about the tool. So assume the situation, your business wants to, this is a request came from your business team saying that they need to implement the driver tracking mechanism in the cab application, and maybe this work is assigned to some guy, let's say Tom. He started working on this problem, and he will implement it. We will wait for him to implement it, and maybe it will take some 5 days to implement. And maybe some other request came from the testing team. They found that from Bangalore location they are not able to book a cab. Then some testing team, probably in every organization there is a team called testing. What they do is they will make sure that your software is running fine, it is doing what it is supposed to do. If there is some problem found, this team will report a problem, and that work is also assigned to maybe a different developer, let's say Jerry. So Tom is working on one problem, Jerry is working on another problem, and there could be multiple developers who is working on different issues. And when they make some code changes, they will actually make sure that they need to make sure that the code changes are available in a central place. I'm going to call it a repository. This repository is something like a smart repository which know who is making the changes and what changes they are making. So whenever Tom is done with his code modification, the code modification he will upload that to a repository. Same thing Jerry will do, and all the developers does that. And it is a smart repository. I'm going to call it Git. Actually, there are different repository tools available. Assume this is a storage space, something like a hard disk. Think about it is a hard disk, but if you install Git on top of it, it would become a smart hard disk or a smart repository which knows whatever changes developers are making. Tom is making some modification, then this repository know by the command of Tom what he is doing, then which file he modified, that it already know. Whenever you make a commit, repository will check what were the changes, then those changes are recorded, which files are modified, which lines were modified, and what were those lines. So complete information of the changes are recorded whenever any developer make a commit. And I am going to call it a commit or push operation. Whenever this commit happens, your repository will record that so that you can later review it. The important thing is that all work done by the developers are available in this common storage or repository. That is most important. It doesn't matter there are 100 developers working, 1000 developers working, all of them will update their work into this repository whenever they are done, which means this repository will have the changes from each and every developers. All right. So I will just talk about one more thing: continuous integration and continuous delivery. These are also the basic to DevOps. I mean, if you are working in a DevOps culture, you should have these two things in your organization: continuous integration and continuous delivery. Continuous integration. Think about this. Tom got a problem. I am going to call it a problem or an issue or maybe a ticket. Sometimes the different organization will use different names for that. Typically, whenever somebody want to make changes into the software product, they will open a problem or issue or ticket, and they will mention these are the issues which I am facing. I am not able to book a cab from Bangalore location, or there is a serious business problem, we should implement the driver tracking mechanism in our cab application. So a short description of the problem would be mentioned in the ticket, and this ticket is assigned to a developer, maybe Tom. And Tom is expecting for implementing this driver tracking, he need 5 days, right? So he thinks that it will take, and there is a Git repository which is ready to take Tom's work. Whenever Tom is done, he will update his work into this Git repository. And Tom is assuming, okay, it will take 5 days to do the job because there are a lot of modification. He need to integrate the map with the Google Map with the application. Then he need to locate the driver in the Google Map. Then you need to calculate the distance between the passenger and the driver in the Google Map. Then it will print a estimated time on the Google Map. You need to calculate that estimated time depending on the traffic condition as well as the distance. Then as the driver move towards the passenger, you need some location tracking mechanism so that driver will keep on updating his location so that you know the location, and based on the new location you will make changes in the Google Map so that passenger will see that the driver cab is actually moving in the Google Map. So a lot of things Tom need to work on. He is expecting some 5 or 6 days to complete this job. So on Monday he started working on something. Nobody knows what he is working on. Tuesday, Wednesday, Thursday, Friday, and maybe next day Saturday. And on Saturday he is done. So assume there is a guy, a auditor or maybe a colleague of Tom. His responsibility is measuring the capacity of your team, what your team can do, what your team cannot do. If I get a immediate work, then I need to decide whether my team can do it or not. If I need to know it, I should know what my team is currently doing and does my team have enough capacity to do it. That is important to know whether before you accept any new job. So this is a guy who is the responsible for measuring the current work, the capacity of the current team, and he is checking the work of Tom. He found that on Monday he checked, he did not find any work from Tom. Tuesday, Wednesday, Thursday, Friday, and on Saturday he found that uh, Tom made a commit and the complete work. Tom finished his work because that is what he expected. That he was his expected time to take for this work, and he did the commit. Then this guy know, okay, in 6 days Tom made this particular change. This is not a very good example of continuous integration. What continuous integration means is the ability of developers be able to make changes to the software application in a continuous manner whenever they want to. They should be able to make their work available. Let's say they are making a small change, then they will make that change available. They will make another very small change, and that small change they will make available. So this commit will happen very frequently because the deadlines of developers will reduce to from 6 weeks to 2 hours or 3 hours. That means every 3 hours he will work on a small thing, he will commit it. He divide his work into very small parts. For example, on Monday he decided to integrate the Google Map. On Tuesday he decided to locate the driver in the Google Map and then calculate the distance between them. On Tuesday he worked on some other stuff. So he he split his work into very small parts, and as he finished these small parts he started committing to the Git repository. Now this guy can see, okay, this is the Monday's work of Tom, Tuesday's work of Tom. Like that you can continuously see the work of Tom. The advantage with this way of doing is you have a better deadline and you can work without much tension. I mean, let's say you know that you need to install Google Map in your software application and you know that it is going to take hardly 1 hour. So let's say for the next hour, 1 hour, your only job is to install a Google Map into your application, and you know that it is possible, right? You have a very better estimate if you estimate it on an hourly basis rather than daily basis, or weekly basis is worse. So 6 days you are making an estimation for a job completion is something like a, it's like a gas. You are just, you are saying 6 days, you are saying just blankly. I mean, it can work or it cannot work, because you don't know when you are going to get stuck, and you don't know when you are going to realize that you are getting more work. Probably you are stuck with something, or you identified only on Friday that actually one more module needs to be set up, which will take time. You don't have a proper estimate, but you know if it on a hourly basis, okay, I will do this now, next 2 hours I will finish this, next 3 hours I am going to finish this, and tomorrow I will finish these things, is more like a continuous integration. And they are making sure that whenever they are working on something, they will make sure that they are making a commit to the Git repository, so that their work is available in the Git repository in a continuous way. So the Git repository will get hourly work rather than weekly work. So whenever developers are working on something, their work is now available in a repository. That is what I mean by continuous integration. I would not call work available in a repository. The definition of continuous integration is that developers are making sure that their work is available. That's it. So you can achieve the kind of continuous integration by using this method. All right. So this is very important that in DevOps, developers must work in this way, so that whenever developers make some changes into the software product, you should be able to put those changes into your infrastructure. I talked about the infrastructure, right? Where you will have a number of machines. Google infrastructure will have millions of machines which will serve the internet traffic. So like that, Ola will have a number of machines which will accept the booking. So it need a number of machines to handle the internet traffic, and this machine should get the updates from Git. For example, developers made some code modification, they put that modification into the Git repository, does not mean that the people on the internet can see those changes. When they try to book a cab, they still won't see the driver is being tracked, because it is still in the Git repository. The work is not delivered to the infrastructure yet, production infrastructure yet. That is when you can see the changes in your software, right? So as per DevOps, and this is a complex process actually, kind of, this is where DevOps come into picture. When you want to make changes to your software product, which is already being used by thousands of people in the market, is a challenge. So what companies do is, there are a lot of steps involved. Typically you won't put your code directly into this production infrastructure. No, maybe the developers could have made some mistake. By mistake they did not add Bangalore location to the allowed places, and you directly putting their code into the production means that you are breaking up something. You should not do it. You should, in any cases, you should never do it. You should never deploy the code changes of your developers into the production. No. So there is a lot of procedure that you need to follow to make sure that everything is done in a smooth way. First, what you will do is you would convert this source code which your developers had committed. You would convert this source code into some executable files like exe file in Windows, or war file, web application executable files, Java applications, then some Debian, some Ubuntu packages. Based on what you need, based on what your infrastructure need, you would convert this source code into some executable files. And DevOps prefer the source code to be saved as executable rather than plain text code, which means that this executable can be deployed to an environment whenever you want to. You cannot directly copy your source code into your machines. That won't work that way. First, this source code should be converted into a machine understandable form, and that is what a exe file or war file is. So you always prefer to save your code. As soon as the developers made the code changes, you would take that code from Git and you would convert them into some executable file which machines can understand. And these are these executables that you are going to copy to your machine. Again, you won't directly copy to your production, right? First, you will have a testing environment within your company. Maybe it will contain 5 or 6 machines, and this machine will do the same job as this production infrastructure will do. Basically, if you point your mobile in within your company, you have a mobile device. This is the mobile device which company purchased for testing. This mobile device, let's say, points to this particular environment, and this environment is accessible only within your company and not internet. People on the internet cannot book a cab using this environment. Those who are on the internet, when they try to book, they will always go to this environment. So this environment is only for your own testing. So you want to make sure you try to book a cab, make sure that it is working. So everything you can do in a testing environment, and that's how organization will do testing. Probably there is a different testing team he is available. They will do it some automated testing. I mean, you don't humans will not connect to the mobile and then try to book. Instead of that, some tools will connect to the mobile and try to book a cab. That is also possible. So it would be mostly it would be automated test, and there can be some manual test also. So there are a number of processes, and after, if everything is looking good, you tested everything, you are able to book a cab, you can see the driver being tracked on the map, everything is looking good. Again, you would deploy into one more environment, maybe one or two environment, and you do the testing in all the environments before you would actually move your executables into the production environment. This is called live or production environment that serve the internet traffic. So what I'm saying is there is a big lot of procedure in place whenever you want to do a release, which means all organizations are facing a lot of trouble here. What they do is they will do release once in a month or maybe once in 2 months, and there are still companies who do releases once in 6 months. What happens if they do that? Whatever work your developers are doing are still in the Git repository, right? Are still in the Git repository, and it is not available to the market. Assume today is your business found that there is a need of driver being tracked by the passenger. So let's implement that. And the developers already did that. They made the code changes, necessary code changes they did. They updated that into the Git repository. But you are not doing a release for next 6 months. Next release is 6 months, means only after 6 months the work of this developer will go to the live environment. It is more like a useless work for 6 months. And even after 6 months, it can be a useless work too, because the business situation will change every month, maybe every day. So after 6 months, this feature is irrelevant, because there are a lot of other features which people are now curious about. This feature is not relevant after 6 months to the business, which means that it is again a useless work. So DevOps says that release is not something that you do, you schedule for one date. Maybe you would schedule that on 1st of July, you want to do a release. It should not be like that. It should be part of your workflow. Whenever your developers are making some code changes, if you want to do the deployment today, should be able to do it today. If you want to do it in the next 1 hour, you should be able to do it in the next 1 hour. For that, you need to avoid all these dependencies. There are a lot of dependencies which I discussed about, and there are a lot more which I have not discussed about, which we will discuss in detail when we are in the course. The code should be converted into executable. The executable should be first deployed into a testing environment, and some tests should be run maybe in an automated way on this environment, and some manual testing should be done. So there are a lot of process involved, right? Assume a sample situation like this. Assume a sample situation. You have the code Git repository here, and the developers are keep on making changes, commits to that Git repository. And you will take the code from the Git repository automatically whenever somebody is making a commit. So let's say there is a tool or there is a automated tool that you have set up. Whenever a commit is made to Git will notify this tool. Some developer made a commit. Please do your job. What he will do? He will take the code from the Git and he will build that into executables automatically. And these executable files are actually a saved in a another repository which will contain all the software components in a executable form, which can be directly put into your working environment. And assume as soon as a new executable file came into this repository, this is the executable repository, I'm going to call it like Nexus or Artifactory or something. As soon as a new executable come here, this tool will notify probably the same tool which you have set up for automation. Now this tool will go ahead and set up, create your, deploy this executables into a working environment. That means a testing environment where your company people can do the testing. So these executables are now deployed into a working environment. Let's say this is your cab application, modifications are also there. All those changes are deployed in a testing environment. And now you can start testing using your mobile device. Are you able to see the driver being located in the Google map? All those things you would need to start testing. So this tool, I'm going to call it a continuous delivery tool, right? I mean, what this tool helps is to achieve continuous delivery. So this tool now, immediately after deploying the production, deploying the executable file into a environment, testing environment, it will notify your testing tool. Probably you will have a testing tool. Every organization will have one. Some automated testing tool which your testing team had written. Your job is not writing any code or not writing any testing scripts. Okay. Your job is for setting up these tools and environments. That is what you would do. So the developers make the code changes, testing team make the test scripts, and you would integrate this test automatically whenever this environment is set up. This test script will start running on this machine and it will generate a report, and the report would be sent back to this continuous delivery tool, your automated tool. And it will read the report, it will check whether everything is looking good, it is showing all is green. Then it will trigger one more thing, just deploy the same executables into a bigger environment for testing again. Probably a multiple environments needs to be tested, and then these executables are copied here. Then again some automated scripts are run on this environment. This will continue until you reach the live production environment which serve the internet traffic, which will contain hundreds of machines. So what if you have achieved such level of automation? It is not just the automation, your infrastructure should also be very dynamic. In case if one machine goes down, you are making some changes to one machine, you are copying the executables into a machine. Probably the user who is currently using your environment should not be denied the service. Probably there is a backup machine at that point which will be able to serve the user, right? You are making some release changes, you are making some code changes on your infrastructure, does not mean that it should affect the existing usage. There are many people on the internet who is still trying to access your cab application and trying to book a cab. They should be able to do it. So probably you should, within your infrastructure also, you should make sure that you have a proper backup so that people are not denied the service. So that is also something part that you need to take care to make sure that your infrastructure will contain a backup for every machine. So a lot of things, all this responsibility comes to you as a DevOps engineer. Mainly you are the one who want to manage this live or production environment. Whenever the changes of the developers, you want to put them into this live environment, it is your responsibility. Or you want to make some changes, you want to install some software on these machines, it is your responsibility. So especially for managing the complete environment is what your responsibility is. And these tools which I have been talked about, right, the tools which I had talked about are the ones that helps you achieve this. Git, you already got an idea what is Git. And is a build tool. I told you DevOps always prefer the code be saved in executable form rather than plain text form, right? And is a tool which you can use for converting your plain text code into executables. And we are not covering it in too much depth. Typically it is more like a developers need to design the code and everything, but you are the one who would do this conversion of source file into executable. So and it's not a detailed topic, it is a detailed topic, a very important topic in our course. And cloud computing is very important in our course. And the ops tools that we are learning, Jenkins, I talked about the continuous delivery tool, right, which will notify the different services whenever they want to. It is done by Jenkins, is a example tool which can do this. And Docker is like a containerization tool. If you want to split your software component on a high level, on the application layer, into different components, that I'm not going into depth of that. Vagrant, we are not covering in depth. Vagrant, Nexus, and Sonar, these three tools alone, it would be a high level discussion. Nagios is a monitoring tool, very important tool that we are covering in the course. Basically, whenever you want to find out if, let's say, any of the machine can go down at any point of time. The internet is unpredictable, right? Any machine can go down at any point of time. Any service, any software running on the machine can go down at any point of time. If any such problem happen, you want to be notified. If you don't know the problem, you won't be able to fix it. So Nagios is a notification tool. It will monitor your infrastructure. If there is a problem, it will notify you by email or SMS or maybe by a call. That's what Nagios is, one of the very important topic in our course. Chef, kind of a config management tool. Whenever you want to install the machines, you have thousands of machines, right? You obviously you would have, you can simply assume that you cannot manually go log into each and every machine and make changes to the machine. It does not work that way. There should be a tool which will take care of setting up the machine, installing the software, copying the necessary files, based on what the machine need. The tool will do everything. That is what the chef is. It is the very one of the most important topic in our course, a detailed course. It itself is a topic in DevOps. It itself is a topic called config management. For example, think about, you want to immediately add some 100 machine to your infrastructure. Google got some traffic, they want to add some 100 or thousands machine to their infrastructure. Maybe they can do it in a by clicking a single button. All they need to do is click on a single button, and some tool, maybe your Jenkins, would notify chef that these 100 machine need to be set up, please go ahead and set up, and chef will do the setting up. No human involvement is required. Yes, it is required just to click on a button. So chef is a tools like that, a very important tool, and it is covered in detail in our course. And Nexus and Sonar, like I said, it would be just high level. Nexus, Sonar, and Vagrant also. The most detailed topics are Git, AWS, cloud computing, AWS, then Jenkins, Nagios, Chef. These are very important DevOps tools. But to learn these tools, you need these Linux basics that we will cover initially. In the first 2 weeks, it would be basics. Maybe not 2 weeks, maybe 7 or 8 days. We need that. And after that, we will move on to the advanced topics like AWS and DevOps. So that is the plan. And every day's videos would be recorded and it would be shared with you in a Google Drive. You all will get access to the recorded videos. And it is a lab oriented course, I told you, right? There would be a lot of work that you need to do. You should have your own lab environment ready. That I will discuss in the first class. In the first class, we will discuss about the lab environment, how to set it up, everything. uh, you should have your own lab environment. Everyone should have their own, and you should have enough time also to work on. I know that there are a few people who is working in the companies. You should spend at least 2 to 3 hours per day if you want to finish the assignment in a proper way. And you need to actually, it is something like a mandatory thing. Whatever assignment are given to you, it will match like how you would work in a real time situation. So unless you do this assignment, you will not clearly understand what is going on. You know that we are learning, we have about 55 hours total. We are learning a lot of tools within this short period of time. So unless you do it practically, it would be even tough to remember things also. So make sure that you are doing the work. At least 1.5 hour the course will take another 1 hour to do your practice. And if you are a fresher, spend your as much as time on as possible. Finish everything, each and every assignment that I am giving you. It is mandatory that every freshers who is in this course should finish those assignments. Otherwise you won't get the clear picture. uh, that is expected actually, kind of. If you are a fresher, it is expected that you would initially, when you work with the Linux terminal itself, it is something like a foreign country. So just you should go in pace with me. Whatever daily work that I am giving you, you should be in pace with me. And by the end of this course, you would be able to start picking up the job. And you know DevOps market, right? Probably that is why all of you are here. This is the market situation today. All companies need to accept this DevOps principle. Otherwise they are going to be out of market within few years. Every companies are accepting it. They are moving towards DevOps, which means a lot of opportunities in DevOps, a lot of them. And it is a highly paid job, and it is a one of the, to me, I believe this is the best job that gives you the satisfaction as well as a good package and flexible timing also. So that is also important, right? Kind of, it's a good field to work on, but of course it is not just not like a simple topic which you would crack like that. You need to finish all the assignment, and you should go in pace all the 45 days that we are covering. And by the end of the training, you can start your marketing. Otherwise you would need to spend more time on finishing your assignment, which is like, which won't be good. If you go in the course, you would do it good. If you pend it something to later, it won't